Today's episode is brought to you by Engineering.com, a globally trusted source for engineering content. Check out this and many other exclusive videos for the engineering professional found only on Engineering.com TV today. Welcome to the Primary Loop. I'm Jim Anderton, Multimedia Content Director here at Engineering.com. You know, engineers designing for the consumer goods industry have perhaps the most challenging task of all. The same performance, cost, and time to market challenges that affect all engineering are there, but they must produce products that also have consumer appeal, and that's a highly complex problem to solve. Traditional market research tools such as surveys and focus groups help, but in sectors such as the automotive industry, a swing and a miss is enormously expensive, and it happens. Now, is there a better way to determine what consumers want to guide the engineering design process with confidence from the outset? Well, Yale's Professor Alex Burnap thinks so. Dr. Burnap studies how companies can improve product management and design using machine learning and big data, particularly generative AI. Before Yale, he worked at product research at General Motors, did a postdoc at the MIT Sloan School of Management, and a doctorate and Master of Science in Mechanical Engineering from the University of Michigan. Alex, you recently co-authored a very interesting paper called Product Aesthetic Design, a Machine Learning Augmentation with John Hauser and Artem Timoshenko on machine learning to optimize product aesthetics. Can we start? Tell me a little bit about product aesthetics. What do we mean in this context?
Sure, Jim. Yeah. So in this context, we're really just talking about the exterior styling of, in this case, automotive vehicles. So in general, we're looking at aesthetics, the visual styling of things like home appliances or furniture or fashion. You know, things that are pretty obvious. Yeah, it probably matters how it looks. But this is, you know, from a general point, a lot of the work we're attacking here really is for any product that was designed with an intent for an end user, which is most of the things, you know, if we look around our world, it's most things, right? Yeah. In this project in particular, we focused on automotive. There, just as you said, a messed up, you know, it can be very expensive. 3 to 5 years of overall, development time, 1 to 2 years of aesthetic, the exterior styling up front, about $3 to $5 billion overall production costs, retooling, manufacturing lines, et cetera. But so very expensive. And you know, before we jumped in, we talked a little bit about the Aztec, and actually we talked about this in our paper because the Aztec was a great case study for us in showing why aesthetics were so important for automotive design. So the Aztec actually shares the same powertrain, you know, engine, transmission. It is actually manufactured off the same line in Ramos Arizpe in Mexico as the Buick Rendezvous. So the Buick Rendezvous, Pontiac Aztec, and actually the Buick Enclave that replaced the Rendezvous, they're all very similar, like internally, just they look different. And, you know, as we talked, I think a lot of your audience and people in general know the Aztec kind of flopped, right? Never hit the 30,000 units it needed to even break even. Program was shuttered after a few years, and it, you know, kind of lampooned as this design failure. Even after all the focus groups were, you know, as we talked, all the focus groups and all this great research had been put in. At the same time, you have the Rendezvous and the Enclave that replaced it. Big successes, right? And from like a experimental standpoint, these were identical vehicles except for the way they looked, right? But the Enclave had a 30% higher MSRP over multiple years of a vehicle line. That's billions of dollars in revenue, right? So aesthetics does matter. Aesthetics is important here.
Yeah, no, I understand exactly what you mean. But I guess the fundamental question, and I come from the automotive industry myself, and I know exactly what you're talking about, is that you can spend millions of dollars in research, and you can focus group something, and you can do everything. The Aztec's a great example because that's the case of General Motors doing everything right. Extensive focus groups, extensive consultation with dealers, a show car that was actually taken coast to coast to gauge consumer reaction. I mean, I can't imagine any more certainty you could engineer into a product for consumer acceptance than that example. And yet it didn't work the way it was expected. Is there a disconnect between what consumers say they love and what they will actually write a check for?
Oh, that's a very big question right there. And a lot of the research, and not just from the academic side, people put a very big notion between stated and revealed preferences. You know, stated, I say I love, you know, to recycle. I call my mother all the time, and yada yada. But then what do? You know, are you actually buying the Aztec? There have been advances in survey methodology, et cetera, but that's always a disconnect we get. And, as it relates to this work we're talking about right now, and which I would love to talk about in a second, I think this idea of of augmenting how people are designing products rather than automating a lot of this. We're going to run into trouble if you try to automate with machine learning too much of the design process. So if we talk about we focus particularly as you start off with on the aesthetic design process itself. So no engineers, no manufacturing engineers, design engineers, supply chain folks, downstream stages. We're talking way up front, market research. Hey, we need, for mid-lux segment C, we need in this region of the U.S. or abroad, we're targeting here. Here's some loose design constraints. That goes to designers, and basically these two stages we looked at: the design ideation or generation stage, and then kind of this down selection of, this filtering stage. And you can almost conceptually think about this as the designers in the company and the market researchers in the company, where the designers are, coming up with all the designs. Some of them don't even have wheels, right? You're like, okay, you gotta winnow that down a little bit. And market research a lot of time with the bad people saying, okay, hey, we did the focus groups. You need wheels. And so we focused on these two stages. And what we did was we came in with machine learning. And if you allow me, actually, maybe for your audience, it might be interesting. We came in, and I was more of a technical engineer from computer science, and I was coming with these cool deep learning generative models, which 10 years ago, now they're really hot, but it wasn't as hot back then. And I came in, I got laughed out of the room because it was so not useful for the company, so not what was actually solving any real problem. And as engineers, that's problem solvers. So after a few years of working to understand what was actually useful, I'm tying this back to these two stages again, this generative stage and this filtering down stage. What we found out was the way to integrate machine learning into the existing design workflow, so it was actually useful, was we gave the designers this generative tool so they could come up with new product designs never before seen to the world. So it augmented them, it helped them, and they could explore, come up with cool ideas, then kind of iterate themselves. And that was at one stage. The second stage was this predictive stage where we took designs that were new to the world and we kind of rated them or graded them. And that was a filtering down. That's kind of what market research already did. So that was a long answer, but that was kind of a short synopsis, I think.
Now that's fascinating. So the question is that are you looking at a future where we have a tool where fairly early in the design ideation stage, in that iterative sort of blue sky thinking stage, are we going to have a tool in which we can pump a rough design, literally a sketch or something in there and say, are we on the right track, and have the algorithm tell us yes or no, change direction?
I think we're on that road, yes, sir. I don't want to be one to claim that this work is doing, I feel like this is a very big problem that will take a lot of, as it has for decades of you can go back to the 80s and think of the CAD tools. And at that point, people were thinking, CAD's going to come in and replace design. It's like, no, it did it. It helps out a lot, though. But I think we're on that road, Jim, because if you look at, take the 80s, you take the 90s, the way that CAD tools integrate further and further upstream, I think this idea of further upstream integration with downstream stages that are easier to simulate from a physics standpoint. So if I come up with the aesthetic design or sketches, as you were saying up here, can CATIA or Autodesk, can some company integrate that all the way down with their finite element analysis or, fluid dynamic kind of CFD stuff? I think that road is in the future. We're
Alex, an old boss of mine once told me, he said, good engineers can find the right answers. Great engineers can find the right questions. With generative design and the kind of work that you're doing, are we looking at a future where the engineer is going to be just completely removed from the loop? Or are we still going to need creative people to basically drive the process?
This is a very big, you're asking very big questions. I have very strong views that might conflict with other views here. I have very strong views that we're very far from automating anything that requires creativity. And I say this even including for ChatGPT and all the other, at the core, these are all deep generative models. We're making cars, ChatGPT is making text, but they're at the core the same. And you're training on everything in the past. And so, the Pontiac asset, cool combinations that you interpolate between prior cars can come up with new design forms. But there's not a lot of three-wheeled cars out there. And there's not a lot of, there's fundamental limitations that only human creativity at this point in time, at least, can get us to. Now, we talked a little bit before the show, but I do think this kind of underpins this whole these tools will augment the designers, make them better, make the marketers better at what they already do, at least for a while, in my opinion, decades, before we have the full-on, automation. So
awesome. Alex Burnap, Yale University, thanks for joining me on The Primary Loop.
Thank you, sir. Thank you so much, Jim.
Well, that's it for this episode of The Primary Loop, brought to you by Engineering.com. For our Deeper Engineering series, visit Engineering.com TV for exclusive shows like Manufacturing the Future, Designing the Future, and the Engineering Roundtable, not found here on our YouTube channel. The links are in the description below. Thanks for watching.